Okay, so chapter 6 is about rationals. Now rationals are expressions of the form p over q, where p and q are both polynomials. So the reason we have to do this after factoring is often it requires factoring techniques to find certain things out. For example, negative 6x over x cubed plus 8 is a rational expression, and sometimes to find out where your function is undefined, you have to factor the denominator. Now, for evaluating rational expressions, when the questions ask you to evaluate, it's still the same as if it were every other polynomial. You simply plug in whatever value that you're asked to evaluate at for x or the other variables. And rationals have something, of course, that normal polynomials don't, and that they have places where they're undefined, because remember the first rule is that you can't divide by 0. So whenever you're asked to find where a function is undefined, you need to find where the denominator is 0. Now, they may ask you to reduce a factor, which is, if it's like 2, 6 can be reduced to 1/3 because it shares a 2, because it's even. Rationals can share a factor like this x plus 3. Now, the only reason we're allowed to reduce is if you can say x can't be negative 3, then you don't have to worry about reducing 0 over 0. Some other rules: quotient of opposites. If you have x minus 6 over 6 minus x, it's a quotient there, and you can reduce it to -1. It basically is by factoring a -1 out of one of them to get there. And equivalent forms: negative a over b equals a over negative b equals negative out front a over b. Technically is also equal to negative a over negative b. We'll talk about that a little more when we see a problem. The general steps for writing a rational in lowest terms is to factor everything, reduce common factors and opposites when possible, and then write out your answer. So let's look at some examples of the types of problems you will have to do in your homework. Starting with evaluating, find the numerical value of the following when x equals 2 and x equals 3. I'll just do one of them, where x equals -3. And we'll plug in 2 to the first one and -3 to the second one, leaving you to do the others. So replacing x with 2, 2 times 2 squared minus 4 times 2 over 3 times 2 minus 1. 2 squared is 4, so that's 2 times 4 minus 4 times 2 over 3 times 2 minus 1. So 8 minus 8 over 6 minus 1. That's 0 over 5, which is 0. Let's plug in -3 to the second one. 7 minus 3 times -3 over 3 times -3 squared minus 7 times -3 plus 2. -3 squared is 9. So this is 3 times 9, 7 times -3 plus 2. -3 times -3 is 9, so 7 plus 9 over 27 plus 21 plus 2. 16 over 50. This can be reduced to 8 over 25. So evaluating is not that different from evaluating in any other situation. So just keep that in mind. Now, finding values for which the rational expression is undefined, you will always just set the denominator equal to 0 in this case. So 5y, when is 5y equal to 0? When y equals 0 by dividing by 5, so you say y cannot equal 0 in this function. Because if it did, you would be dividing by 0. Looking over at 4, so 3x minus 4 equal to 0, so 3x would be 4, so x is 4/3. Specifically, you can write this as saying 3x minus 4 cannot be 0 to get down here, that x cannot be 4/3. Or you can just get your solutions and then remember at the end, these are the things your variable cannot be. R squared minus 5r plus 4. Set it equal to 0. Factor, this is r minus 1, r minus 4. Means r minus 1 equals 0 or r minus 4. Either one can be 0. So here r cannot be 1, r cannot be 4. So there's two values it can't be. Now lastly, x squared plus 2 equals 0. Which means x squared needs to be negative 2 in this case. Can't really take the square root here because x squared can't equal a negative. So that means all values are fine, which is possible. This thing is always positive. It can't be equal to 0, which means there are no values for which the function is undefined. So that is a possibility when you're doing these problems, depending on what's in the numerator and denominator. Okay, so write each expression in lowest terms. Seems factor everything when possible. If it's just a monomial, you just divide as needed. We know that r can't be 0 from our denominator because that would make us divide by 0, which means I can reduce this. 18 divided by 6 is 3. R cubed divided by r is r squared. Sometimes when you reduce, you no longer even have a rational at all. I'll leave 2 for you to do. Let's do number 3. This is 20m squared minus 45m squared over 6m minus 9. Okay, so factor everything. Let's start by factoring out a common factor. 20 and 45 share 5. So this becomes 4m squared minus 9n squared. 6m minus 9m, they share 3. 2m minus 3. This can be factored. It's the difference of squares. So our numerator would be 2m minus 3n and 2m plus 3n. Over 3 times 2m minus, sorry, this was 3n, minus 3n. Now you see these are the same, so we can remove them, reduce them. We know that 2m can't equal 3n. If it did, we would already be dividing by 0. We don't need to write that anywhere. So when we cancel these out, all we're left with is 5 times 2m plus 3n all over 3. Now your homework may want you to multiply this out. Call it 10m plus 15n over 3. But I think either one of these should be fine. Just remember your homework can be finicky, and we will continue in the next video.